Okay, so welcome to part 3 of the 3D Flange video. We've previously made the base, we have made a box to represent what's going on here, and we just made a box coming up to be kind of where my mouse is moving, that little section there. I'm doing everything in the positive right now, so I'm an optimist. But what I'm doing is I'm doing shapes that add to my overall shape, and then I'm planning to come back and remove things that I don't need. Okay, so what I'm working on next is I want to add this last little bit onto here. I want to do all my box shapes. Why not? I'm doing boxes. Let's just stick with boxes. You could do this another way, but this works. I might come back here and I might do my wedges next, and then I'm going to start setting up for how I'm going to remove stuff. That's just, like I said, that's just one way to do it. There are a bunch of different ways you can do this. So let's go back to auto. Well, before we do, let's look at what we need to add. So we're adding onto the back about 3/8 of an inch. So I'm going to go ahead and write that down for the y coordinate. I'm going to need 3/8 of an inch. Okay, that's my y. That should be a positive 3/8. And my x is going to be the same, 3 1/2. And then my height, if I start at the top of this, my height is going to be 3/8 of an inch as well. And then if you look, so I've got like a rectangle here, I've got a space, and then I've got a rectangle here. And I just need to decide, do I want to do two, let's see, do I want to do one box and remove, use subtraction to get rid of this section, or do I want to make this box, then leave a gap and make this box? And it really doesn't matter a whole lot what I choose to do here. So we see that depth is 3/8. We need an overall width of 1 9/16. So that tells me that this little bit is bumped out a little bit from the back too. So now I need to do a little bit more math, because I don't think 3/8 is my y now that I see that. If I'm starting at the back of what I already have, that would be right here. Okay? From the front of this all the way to the back is going to be 1 9/16. Okay. So what do I already have? I already have 3/4. So to find out how much extra I need, I'm going to take my 1 9/16, and I need to subtract 3/4. I know that it's easy to make 3/4 into 16ths. I know that it's not possible to make 16ths into 3/4 or into fourths unless I'm dealing with, 4/16, 8/16, and so on. So let's not worry about that. Let's take 3/4. So 3/4 is equal to 6/8. 6/8 is equal to 12/16. Excuse me. Okay. All I did is multiply the top and bottom of each fraction, numerator and denominator, by 2, and then I did it again until I got the denominator that I wanted to have. So now I'm taking 1 9/16 minus 12/16. In this sort of situation, I borrow. I'm sorry that you can't see the math that I'm doing. I suppose I could pull up Paint here. That might be a good option for those visual people. So I've got 1 9/16. Sorry, drawing with the mouse is not anyone's. I'm not good at it. I shouldn't say nobody's good at it. You might be, but I doubt it. Okay, minus 12/16. So what I do in this situation is I borrow, right? But how do you do that? Because it's a fraction. Well, I borrow the equivalent of 1. So a number equal to 1 that has 16 in it. So I have 16/16 plus 9/16. So 16 plus 9 is going to be 25 I don't add denominators. 25/16. Oh, we can't have that, math teachers say. No, we can't, but we're still working with this number because it's easier to understand this way, and it's still equal to the correct number. So take 25/16 minus 12/16. We do not subtract denominators. We only subtract the top. So that's going to be 25 minus 12 should be 13. 13/16. Okay. So that's the amount I need to go back from the back. I already went 3/4. I need to go 13/16. If I don't know how to type that in as a decimal, I go to my calculator. I do 13 divided by 16. We could do that on Microsoft Paint too, but I like you too much to do that to you. So we're going to take that number. That number is 0.8125. Just give me a cursor that can actually give me a dot of significance. Oh, I don't want to mess with that stuff right now. We'll go 8125. 8125. Sure, those look kind of like numbers. We'll go with it. Okay, so that is my y. So let's see. So I'm at 3.5 by 0.8125. And my overall height, I think I'm just gonna do one of the, no, with the shape, I think it's easier to do, one big one of these. So let's look at our height again. Get out of here, Microsoft Paint. Okay, so now I've got 3/8, 3/8, and 3/4 to add to be my total height. Okay, 3/8 plus 3/8, 6/8. That's equal to 3/4, because 3/4, if you multiply it by 2/2, is 6/8. So can you do 3/4 plus 3/4? You should end up with 1.5 inches, 1.5 inches, or 1.5. So if I start at the top of this, it'll be a negative 1.5. Now, it was kind of a long time just to get that measurement, and that's going to happen sometimes in design. When I design things for the real world that I'm going to print, especially if it matters how big it is, I sit there with a dial caliper, and I measure stuff out with the caliper. If I'm not sure, I'll measure a thing that I want to reference it to see if it's the right size. So there's a lot of math involved in design, and it gets to be fun when you actually care about getting the right answer. That's what I like about design, is I do actually end up caring. Okay, let's do a box. For this one, I want to see behind the shape, so I'm going to look at it from a northwest isometric. Would you look at that? I'm going to define my plane with 3 points. I'm going to go 1. I have X going up this way. Why don't you grab that corner, X? I'm going to shift right click, go to end point. There we go. I don't know why I didn't want to do that. And then I'm going to go right here to this end point. Now my work plane is on this surface. Okay. So, one thing to point out, my Z is coming out this way. Okay, my Y looks like it's going that way. I don't really like that. X, Y, Z. Let's tip it that way. They're calling that a northwest isometric, so I've got X going that way, I've got Y going that way. Got Z going that way. I guess that is what I set myself up for. So I'm gonna work with it. Okay, so that just means my Z and my Y need to flip in what order they are. That's okay. So I'm doing a box. I'm going from here. I'm actually going the opposite corner is gonna meet up with that one. So the length of it, let's just go with the opposite corner. The X is gonna be at 3.5. So I want to go up that way, 3.5. And the Y coordinate is going to be that, where's my number there? My negative 1.5. It's actually going to be a positive 1.5 just because of how this shook out. 1.5. Let's put it there and see. It didn't like that. That's Z. That's Z, AutoCAD. All right, we'll try again. Box. Let's choose right here. We're going at 3.5, comma, 1.5. Okay. That time it took it. Who knows? And now I'm going to go up 0.8125. All right. Let's take a look at our world coordinate system. Sometimes using the view cube, I mean, I could click this corner. Sometimes that's fine, but sometimes it's just easier. I want southwest isometric. I'm going to go there. Okay. I'm starting to see. It looks like a washing machine. So the next thing I need to do is cut out that little bit here for that little groove in the back. So that groove we know is down 3/8 from here. We also know that it is 3/4 of an inch this way, and it's 3/8 of an inch this way. So 3/8 and 3/4 are the numbers I'm going to work with. 3/8. Let's see, 3/4. Okay, I may need to come back and look back at that. We will see here. Okay, let's go to AutoCAD. Let's go back to our northwest isometric.